Everyone, today I'd like to talk about electrostatic forces. So what is an electrostatic force? So electrostatic force is the electrical force that basically acts between two point charges which are at rest. And it is very important for the two charges to be at rest, and the reason for that will be described later. So it's the force between two charges at rest. So if the charges were not at rest, right, if they were moving, then you have additional forces that could also come, such as magnetic forces. So does anyone know what is the other common name for electrostatic force? It's named after some guy. Pardon? Yes, it's Coulomb's law. And it's named after Charles Augustin de Coulomb, who was a Frenchman who actually sort of studied the electrostatic forces between charges. This is a very common force that you observe every day. For example, if you take a ruler, especially if it's a dry day during winter, and you sort of rub your ruler on your hair and you keep it near pieces of paper, you see that the paper gets attracted to the scale, the ruler. Sorry. The reason is because charges get transferred when you sort of apply friction on your hair. And because of that, the ruler gets charged to one particular charge, and the paper is at the opposite charge, and they begin to attract each other. So, so whenever you sort of try to understand these forces, it's very important that you need to describe them mathematically. So, so that's what I'll go into. How do you describe these forces mathematically? So, so the first thing we need is a coordinate system. So, which basically is a combination of three axes. So I'll label them as X, Y, and Z, which basically refers to the three different directions in three-dimensional space. So I'll go over some of the notation that I will use. So the first one is any point in this three-dimensional coordinate system will be represented by three coordinates, which I'll call as X, Y, and Z, which are basically just three numbers that tells you how to locate this particular point in the system. And from basic geometry, we know that any point in a coordinate system can be represented by a vector. And a vector is nothing but a line that basically connects two different points in this coordinate system, and hence it has both a length as well as a direction. So we define something called as a position vector. Which is basically, which I'll represent by R, which is given by, in this case, if for the position vector to the point x, y, z, it would be written as x I cap plus y j cap plus z k cap, where x I cap, j cap, and k cap are three unit vectors along the three different directions. So for example, in this coordinate system, I cap would be a unit vector, which is basically a vector of length 1 along the x direction, and j cap would be the unit vector along the y direction, and the k cap would be the unit vector along the z direction. So, so that's how you define a position vector. So let's go back to Coulomb's law. So, so consider that there are 2 point charges. One point charge located here, which I'll call as Q1, located at, say the coordinates is x1, y1, and z1. So x1, y1, and z1. So like I've represented here, I can represent this point as x1 I cap plus y1 j cap plus z1 k cap, and which will be represented by a vector r1. And similarly, I have another charge located at a different location, q2, and its coordinates are x2, y2, and z2. And similarly, we can have a position vector that connects to this q2, which is represented by r2. Then the force between these two charges is given by the following expression. So the force between the two charges in vector notation is given by some constant times the product of the two charges, q1, q2, divided by the magnitude of the vector that connects the two charges, which is this vector, which if you remember from vector addition can be given as r2 minus r1. The magnitude of this vector cubed times r2 minus r1. And so you can see this is actually a sort of a line outside force. So if you have two charges here, and this is the direction of the vector r2 minus r1, the force acts along this direction. So for example, this charge would get pushed this way, and this charge would get pushed this way. if they had the same sign. And
All right,
Yeah.
I'm gonna pause you there.